Hello everyone, my name is Stergiou, and for this presentation I'll be showcasing our recent collaborative work named Refine Activation Downsampling with SoftPool. CNNs utilize pooling to increase the receptive fields and reduce the computation requirements. The majority of downsampling approaches are divided into two different categories. The first set of methods aim towards creating a mixed signal from both the average and maximum pooling through either probabilistic, sampling, or other learned approaches. The second set of methods are focusing more towards subnetwork architectures that use attention-based mechanisms in order to distinguish silent features from the input. A key aspect when downsampling information is maintaining balance between the information requirements in the output and the minimization of computational requirements. For this, we propose an exponential maximum weighted downsampling approach, which we term SoftPool. Given activation map A, we define a region R of activations, which we index by I, and for each kernel region R, we can define a weight which is computed based on the exponent of its activation divided by the regional sum, therefore creating the softmax within the kernel region. The downsample activations are calculated through the sum of every per-kernel region activation through their respective weights. During bifurcation, grades are calculated for the outputs of the activation within the region, and the calculation of the gradients with respect to the input can then be done by using the weight that's been calculated for each activation within that region times the gradients for the output of the region, therefore creating a direct mapping between the outputs and the inputs. Information loss during compression can be attributed to the methods used. More specifically, borders between low and high frequency regions have been misrepresented. With SoftPool, however, we can show that we can better preserve patterns in such cases, even when the compression and subsequently the kernel size is large. We perform tests of image similarity, image and video classification, as well as object detection. In our test on image classification, we can show that by replacing the original improvement layers with a proposed SoftPool can yield consistent improvements throughout all the backbone architecture that we've tested. Most of our tests are done in two ways. One is by using the pre-trained weights and then directly replacing with SoftPool, and the second one with replacing layers with SoftPool and then retraining the network from scratch. In both cases, we can show improvements from the originals. The same is also observed when using data of increased number of dimensions, more specifically spatial temporal data. Therefore, in our test for video actual recognition, the replacement of network layers yielded as well consistent improvements over the overall accuracy scores from the original networks. We test our results on HACS, Kernel 700 and UCF 101. To overview, we have proposed a soft maximum weighted pooling method to address information retainment without additional computational overheads. The pooling method is differentiable and can therefore produce gradients for each activation within the pooling kernel region, thus allowing the calculation of gradients for each activation within the region. And we evaluate our pooling method on image similarity, image classification, object detection, and video classification. Our code is available on GitHub. Thank you for your attention.